Hello everyone, wishing you all a very good afternoon. I hope you all are safe, happy and healthy. Am I audible and visible to all of you? Can you see me? Can you just wave your hand or raise your hand and let me know that I am audible and visible to you? Okay, great. So, up till now, what we have done is we have covered more than 2/3 parts of electrostatics. We have covered what do you mean by electric force, electric field, electric potential, potential energy. The last class we dealt with Gauss law, electric field lines, electric dipole, properties of conductors, and we have seen almost all types of questions that are possible in that particular section. In today's class, what we are going to do is we are going to start with the next and the last topic in this topic of electrostatics, which is known as capacitance. So we start with capacitance. Just give me a minute. Okay, so we are going to start with the topic of capacitance, and the first thing that we must understand is what do you mean by the term capacitance? Anyone can tell me what do you know about the word capacitance? What do you mean by capacitance? Anyone, any idea about the term capacitance? Anyone can tell me anything about capacitance? What do you mean by capacitance? Now, in most of the books, what you will see is whenever you hear this term capacitance, you will always see it is written in this way that capacitance is the capacity or ability of any conductor to store charge. Most of the books will tell you this is the ability of a conductor to store charge. I won't say that it is incorrect. I won't say that it is incorrect. Reciprocal of resistance, not Vishnu, not entirely. Reciprocal of resistance, yes, in many cases, in fact, in all cases, whatever you do for resistance, the reciprocal is done for capacitance, series combination, parallel combination. I understand that. But you can't call capacitance as the reciprocal of resistance. No, capacitance is not the reciprocal of resistance. Numerically, yes, wherever resistance comes in the numerator, capacitance will come in the denominator. Doesn't mean that it means the reciprocal of it. What capacitance means is the ability of any conductor, the capacity of any conductor to store charge is what you will find in books. It's better instead of using the term charge, you use the term energy, or more precisely electrical energy. So capacitance, as the word suggests, is the capacity or ability of any body, any conductor to store electrical energy in it. Do we understand this? Capacitance is the ability of any conductor to store electrical energy. Some people may call it charge. You can call it as charge, but the better word is to store electrical energy. Now, how do you find this capacity? This capacity of this conductor to store electrical energy is known by the name capacitance, and we denote it by the letter C. Now, this C is sometimes known as the capacitance of the conductor. Now, on what all factors this capacitance of the conductor depends on? Now, we have found it by experimentation, by doing a lot of experiments on these capacitors or conductors. We have found out that whenever a conductor is charged, its potential increases. It is found that for an isolated conductor, the potential for an isolated conductor, we are assuming that the potential is 0 at infinity. If we consider that the potential is 0 at infinity, we found out that the charge on that conductor is directly proportional to the potential difference. Whatever charge we can store, that is why sometimes it is known as, some people call it, that would be a better way of saying this, some people call it the ability to store charge. It is basically the ability to store energy. So Q becomes equal to CV. This C is a constant, which is known as the capacitance of this conductor. And on what all factor this capacitance of the conductor, of an isolated conductor, depends on? On what all factor this capacitance of an isolated conductor depends on? We'll see this, but let us first of all see some important points. How do you define this capacitance? Capacitance of a conductor is the charge required to increase the potential of a conductor by 1 unit. This is how you can define it. It is a scalar quantity. The unit of capacitance is farad, but it is a very big unit. You must be knowing that farad is a very big unit. The normal used units, we use smaller units, and we use the units of microfarad or nanofarad or picofarad. 1 farad, capacitance of 1 farad is a very big unit. So in day-to-day life, we don't encounter capacitance in farad. In day-to-day life, we will encounter capacitances in micro, not even micro, in picofarad, 10 raised to the power minus 12. That is the order in which you will encounter capacitance in your day-to-day life. What else? As I said, what all factors the capacitance of an isolated conductor? Remember, we are using specifically the term isolated conductor. So that means there is only one conductor. You must be amused, sir. Whenever we have read about capacitor, they're always in pairs. There are always two conductors, one positive, one negative. What is that? We'll come to it, don't worry. Right now, what we are dealing is capacitance of an isolated conductor. Do we understand this? Can I have some raised hand? Sir, we are dealing with something known as an isolated conductor, one conductor. It could be a plate, it could be a sphere, it could be a cylinder, it could be anything. If you have one conductor, what is the capacitance of that isolated conductor? Can I have some raised hand that we understand this? Teja, Vishnu, do we understand this, beta? Okay. So this capacitance of this isolated conductor, what all factor it depends on? It depends on the size and shape of the conductor. Definitely, if you have big conductor, the capacitance could be more. If the size is changed, the capacitance or the capacity of storing energy would change. It depends on the surrounding medium, whether it's surrounded by air or water or chlorine or hydrogen. It depends on the surrounding medium, and it also depends on the presence of other conductors. If there is one conductor which is isolated, but if you put another conductor, then things happen. What happens? We will see that. Don't worry. But right now, what we are dealing with is the capacitance of an isolated conductor, and these are the factors on which capacitance of an isolated conductor depends on. Am I clear with this point? Now, since we have understood on what all factors it depends on, we must also understand on what factors it does not depend on. First and foremost, charge of the conductor. You will say, sir, Q is equal to CV. Q is equal to CV. So it must depend on Q. More Q means more C. No, more Q does not mean more C. More Q means more V. C remains a constant. It does not depend on the potential of the conductor. You will again say, sir, more V matlab less Q. No. More V means more Q, not less C. It does not depend on the potential energy of the conductor. Remember, capacitance of an isolated conductor only depends on its size, shape, and the surrounding medium and the presence of other conductors. Do we understand this? Can I have some raise hand that we understand this, sir? Okay. Now, every capacitor will store charge. The better way is saying stored energy. And therefore, how much is the energy stored in a capacitor? Potential energy or self energy, we call it, of an isolated conductor. And you can easily call it as Q square by 2C. I will not go into derivation part, or half CV square or QV by 2. How is this energy stored? Please remember, this self energy is stored in the form of electric field. Remember, energy stored per unit volume in a space where there is electric field is given by half epsilon naught E square. We did it in the previous chapter. Wherever in space you have electric field, in that space, what is getting stored? What is getting stored? In that space, what is getting stored? In that space, electrical energy is getting stored. How much energy is stored per unit volume? This is known as energy density. You can also call it electric energy density. For magnetic field, it will be magnetic field energy, electric field energy, or electrical energy per unit volume. Energy density, electrical energy density, density of energy per unit volume is half epsilon naught E square. Can I have some raised hand that we understand this, sir? Coming back to the same thing, whenever you have a conductor and you put charge on that conductor, that charge creates electric field. Electrical energy is stored in that electric field, and the ability of this conductor to store electrical energy is known as capacitance. Can I have some raised hand that we understand this, sir, so that I can move forward? Do we understand this? Bhojraju, Akansha, Saiteja, Pawan, do you understand this beta? Capacitance is the ability of a conductor to store energy. Done and dusted. We come to the next point. Capacitance of an isolated spherical conductor. I will not again go into the specific of this. How do you get it? If it is in vacuum, it will be 4 pi epsilon naught R. If it is in a medium, it will be 4 pi epsilon naught KR, where K is known as a dielectric constant. I hope you know this. Capacitance in medium divided by capacitance in air is known as dielectric constant. I hope we all know this small thing. Just so know. Now, we did this thing in the previous class also. What happens when you have two charge conductors? This is one charge conductor. This is another charge conductor. Their charges may be different. Their dimensions may be different. Their potentials may be different. If you connect them by a wire, we call it conducting wire. If you connect them by a conducting wire, what will happen? If they are at different potentials, charges will start to flow. Charges will start to flow. Flow of charge is known as electric current. That is the next chapter. We'll come to that chapter, don't worry. Flow of charges will start. How long will this flow continue? How long will this flow continue? This flow will continue unless and until both the charges, not both the charges, both the potential of both the conductors become same. So charges will flow till both the conductors come to the same potential. If you want still to keep the flow of charges, we must have some source that can provide potential difference. And that source is cell or battery. And this cell or battery will cause a continuous flow of electric charges. And that becomes electric current, your next chapter. Right now, what we are going to do is we are going to have two charge bodies at different potentials. We will connect them by a connecting wire. Charges will flow. Point number one, whenever there is a potential difference, there will be a flow of charge. Which charge will flow from where to where? You all know this. Positive charge, not mentioned here. Positive charge will always flow from high potential to low potential. Negative charge will always flow from low potential to high potential. The flow of charge will continue till there is potential difference. If you can create a constant potential difference with a battery does, you will be able to continue this flow of charges forever, 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 forever. Am I clear with this concept of flow of charges? Am I clear with this concept of flow of charges? So what happens before connecting the conductors? The capacitance of the first conductor is C1, other conductor is C2, charge is Q1, Q2, potential is V1 and V2. But what will happen after that? After you have connected these conductors by a connecting wire, after connecting the conductors with a connecting wire, what will happen? Everyone know this. Capacitance does not change. Remember, charge becomes Q1 dash, Q2 dash, potential becomes same. And you must remember that the charge remains conserved. So Q1 plus Q2 will be equal to Q1 dash plus Q2 dash. Do we understand this? And the potential must be same. So Q1 dash divided by C1 will be equal to Q2 dash divided by C2. You can solve these two equations. You will get the ratio of the charges. Remember, the ratio of charges is same as the ratio of capacitance. More charge will be on the capacitor, which has more capacitance when you share the charge. If the capacitance is less, you will have less charge. So these are the equations that you get. And this is the final charge on capacitor 1. This is the final charge on capacitor 2. And this is the final potential difference. Some energy is always lost whenever you make a connection in the form of heat. This energy is this one. You must remember these 3, 4 formulas. I hope you will remember this. I have already sent you this sheet. I hope you can go through this sheet. You can go through this sheet and read it once. I hope you have noted this formula. If you have noted this formula, here comes a question right there on your screen. You have two isolated conductors, A and B. The capacitance is given, the charges are given, initial charges. The capacitance of A is 3 microfarad, charge is 3 microcoulomb. The capacitance of B is 3 microcoulomb. The charge is 3 microcoulomb, capacitance is 6 microfarad. What is the final charge? What is the heat produced? What is the common potential? I'll give you a minute to win it. Minute to solve the problem. Else I will do it for you. I hope you have done this. How will you do this? Charge on the first capacitor. We already know the formula. We put the formula. It is directly proportional to the charge. It is directly proportional to capacitance. Look at the formula here. See, this is the formula Q1 dash. Oh, you can't see it. This is the formula. Q1 dash is C1 upon C1 plus C2 into Q1 plus Q2. This will give me the charge on the first capacitor. The second capacitor will be C2 upon C1 plus C2 into Q1 plus Q2. The final potential difference is C1 V1 plus C2 V2 divided by C1 plus C2. And the heat loss will be half of C1 C2 upon C1 plus C2 into V1 minus V2 whole square. I hope you understand this. There are 1 or 2 more questions given on this. I'm sure you can solve this question on your own. Please solve them. As I told you, what if you solve all the questions given in the sheet that I have sent you, it is more than enough for you to crack the JEE this time around. Capacitor. What do you mean by this capacitor? Now you come to that portion that you are probably aware of. What is a capacitor? Now what I do is, we have found by experimentation that if you bring, when an uncharged conductor is brought near to a charged conductor, the charge on the conductor remains same, but its potential decreases, resulting in the increase of capacitance. In fact, if I bring two conductors close, if I give this plus Q charge and if I give this minus Q charge, we have found out that the combination this combination has more capacitance than these two isolated conductors alone. So if I have one isolated conductor, I calculate the capacitance of this, and I calculate the capacitance of this, and then I calculate the capacitance of this combination, which is two conductors, equal and opposite charges, placed at a small distance d apart. We found out that the combination wala capacitance is much more than their individual capacitance, and this combination of two conductors having equal and opposite charges placed at a small distance from each other is known as capacitor. This is known as the positive plate of the capacitor, and this is known as the negative plate of the capacitor. The potential difference between these two plates is now known as potential of the capacitor. Charge on the positive plate, remember, not the net charge. Net charge may be zero. Is it always zero net charge? No, it may not be always zero. Charge on the positive plate, the positive side of the plate, is known as the charge of the capacitor, and we have found out that this charge on the capacitor Q is directly proportional to V, where V is the potential difference of this capacitor. Q is equal to CV. This C is a constant. On what all factor this C depends on? This C is a constant, and this constant is known as the capacitance of the capacitor. This combination is known as capacitor. On what all factor this capacitance depends on? It depends on the area of the plate. It depends on the distance between the plates. It depends on the dielectric medium between the plates. So this C depends on all these three things. Do we understand this? Can I have a raise hand that we understand this, sir? Then again, you have the energy stored in this capacitor, half CV square. Remember, C is the capacitance of this system, which is known as capacitor, and V is the potential of this capacitor. The potential of the capacitor is the potential difference between the two plates. One is the positive plate, other is the negative plate. This is how we define it. This is how we draw it. I hope every one of you understands it, and this is the time that we move ahead with this. Do we all understand this? Capacitance. Now, depending on the type of plates, we can have different types of capacitor. Do you have any idea of what are the different types of capacitors that you will come across? Anyone can tell me what will be the different types of capacitors that we come across? Anyone can tell me what are the different types of capacitors that we come across? No one? Have you heard about a parallel plate capacitor? Have you heard about a parallel plate capacitor? Yes or no? What all types of capacitors have you heard about? Are there any more types of capacitor that you have heard about? Spherical capacitor, have you heard about spherical capacitors? Yes or no? Do you know what is the capacitance of a spherical capacitor? Do you have any idea about them? Spherical capacitors, cylindrical capacitors. Have you heard about these terms? Yes or no? No? Probably it will take some time. Okay, not to worry. We will, I will show you this one. I thought that you might be aware of this. I will, don't worry, nothing to worry about here. If we don't know, I am here. I am here to clear all your doubts. Don't worry about this. So, the first type of capacitor that you might encounter or come across is known as a parallel plate capacitor. Have you seen this capacitor before? Yes or no? You must have seen this capacitor before, right? It basically consists of two plates which are arranged parallel to each other. Does it ring any bell? Two plates arranged parallel to each other. Now these two plates in most of the cases are rectangular ones. You can see here. It can be triangular one. It can be of any other shape. So this is basically a parallel plate capacitor. How do you calculate this capacitance? Basically, beta, and any question you are asked to calculate the capacitance of any system, what you do is you give a charge Q, plus Q on the positive plate and minus Q on the negative plate, or plus Q on the positive plate, and then you find out the charge on the negative plate. Then you find out the potential difference between the two plates. How will you find out the potential difference between the two plates? You can find the electric field between the two plates, and from that electric field, you can find out the potential difference. Once you find out the potential difference, you can use the formula Q is equal to CV, and from that you can calculate the capacitance of this capacitor. Look at the case here. I have got two parallel sheets. I have given this plus sigma charge, minus sigma charge. Plus sigma means it is positive plate. Sigma is charge per unit area. You remember charge per unit area. So I give it plus sigma, I give it minus sigma, then I find the electric field between the plates. The electric field will be sigma by epsilon naught. The epsilon naught is the absolute permittivity of the space in between the plates. From here, this electric field is constant. So from here, I find out the potential difference between the two plates. And from here, I find the capacitance and I get the formula K times, I will just write this epsilon R as K times epsilon naught A by D, where K is known as the dielectric constant. If the medium is air, K becomes 1, and capacitance in air becomes epsilon naught A by D. It depends on epsilon naught. That means it depends on the medium. It depends on A, that it means directly proportional to area. More larger the place, larger is the capacitance. It is inversely proportional to D. That means less the distance, more is the capacitance. Do we understand this? Can I have some raise hand, beta? That we understand this? Okay, great. I hope everyone is following me. The other type of capacitor that you might encounter is a spherical capacitor, though IT says that it is not in its course, but they can definitely ask any question on this type. So there are different types of spherical capacitor that you can make. The outer plate is earth and charge plus Q is given to the inner plate. Charge minus Q is induced on the outer surface of this plate, and the other surface will become chargeless because it is connected to plate. It is connected to earth. Here you can find out the capacitance of this system, and the capacitance of this system is this 4 pi epsilon naught into K epsilon R की जगह K R1 R2 upon R2 minus R1, where K is the dielectric constant of the medium in between the two plates. In between the two plates means I'm talking about this space, whatever is filled in this space. And the formula is very simple. It is 4 pi epsilon naught into K R1 R2 upon R2 minus R1. Do we understand this? Do we understand this? So this is outer sphere is earth and charge is given to the inner sphere, this configuration. Now you can have a different configuration in which the inner sphere is earth, and outer sphere is given a charge Q. You have to find out the charge on the inner sphere, then you have to calculate the electric field between the two spheres, and from there you can find out the capacitance of this system. Remember, the capacitance of this system is 4 pi epsilon naught R2 square upon R2 minus R1. There are different ways of doing this question. I will tell you when we come to that part how this has been done. Inner sphere earth, outer sphere given a charge. This is the capacitance. Will you remember this, everyone? Can I have some raise hand that we understand this, sir? As far as the JEE course is concerned, only parallel plate capacitor is a part of your course, but they can very well ask you what is the cylindrical capacitor, inner cylinder, outer cylinder. Charge is given to the inner cylinder and the outer cylinder. You find the potential difference, you find the electric field potential difference, and you find the capacitance. And the simple formula is this one: 2 pi epsilon naught L upon log to the base E ln R2 by R1. What do you want to know about parallel capacitor, beta? What do you want to know about parallel capacitor? A parallel capacitor is two plates arranged parallel to each other. That is what you see here, two plates arranged parallel to each other. You find the electric field between the two plates. From there, you calculate the potential difference. And from there, you can find the capacitance. It will be K times epsilon naught A by D. A is the area of the plates. D is the distance between the plates. Am I clear, beta? Don't worry, I'll be sending you this sheet also. I forgot to send you this sheet, but I will send you this sheet also. Okay, now there are some key points that you can remember. Some key points that you can remember. Whenever we talk about area between the plates of a capacitor, remember it is the area which is common to both the capacitors. So we call it the area of overlap. So if you have capacitor like this, you only take into consideration the area which is overlapping. Are you getting my point? If they're overlapping completely, you take that area A. If they are not overlapping completely in the formula, you only use the area that is getting overlapped. Am I clear? Electric field between the plates of the capacitor is shown in the figure. So you see in between the plates, the electric field is uniform, but on the edges of the plate, it is a bit non-uniform. We call it the edge effect. We normally neglect these edge effects when you are solving different questions. Do we remember this? Edge effects. We will not take these edge effects when we are solving questions. Now we have combination of capacitors. What is the combination of capacitors? If capacitors are arranged in such a way that the same charge flows through them, you can see the same charge flows through them. And all these capacitors are initially uncharged. If all the capacitors are initially uncharged and the same charge flows through them, then what will happen? Charge coming on each capacitor would be same, but the potential difference across each capacitor will be different. Such combination is known as series combination. Charge on each capacitor will come same if they are uncharged. Remember, if they are charged previously, initially, same charge will not come, but same charge will always flow. The potential are different. You can easily find the effective capacitance in this case. The effective capacitance in this case, 1 by C effective or 1 by CS will be 1 by C1 plus 1 by C2 plus 1 by C3. Someone said in the beginning of the class that capacitance is the reciprocal of resistance. Maybe what he means or she means is this. In case of series resistance, the resistance is given by R1 plus R2 plus R3. Wherever resistance comes in the numerator, capacitance comes in the denominator, and vice versa. But that doesn't mean that they are reciprocal of each other. Am I clear? Then I have another combination. In this combination, charges on each capacitor are different, but they are subjected to the same potential difference V. So they are connected across the same battery V. Such combination is known as parallel combination. Potential difference across each capacitor is same, but charge on each capacitor is different. Series combination. 1 by CS was 1 by C1 plus 1 by C2 plus 1 by C3. In parallel combination, it becomes C parallel will be C1 plus C2 plus C3. Similarly, if we had to calculate the equivalent resistance in parallel combination, it will be 1 by R1 plus 1 by R2 plus 1 by R3. So when we are doing questions on series parallel of capacitors, we are also doing questions on series parallel of resistances. The only difference is in capacitors, when they are connected in series, you get the equivalent resistance by 1 by C1. In resistances, you get it by R1 plus R2 plus R3 and the vice versa in the case of parallel combination. Do we understand this? Now there is a small question based on this, so please solve this question. Capacitor C, 2C, 4C up till infinity are connected in parallel. What will be the effective capacitance? How will you get the effective capacitance? You will just simply add them. So the effective capacitance becomes infinite. But if they are connected in series, C, 4C, 16C, what will be the effective capacitance? In this case, 1 by C equivalent will be 1 by C, 1 by C plus 1 by 4C plus 1 by C. This is an infinite GP. It's an infinite GP with the common ratio less than 1. So you can use the infinite GP wala summation. You use infinite GP wala summation, A upon 1 minus R. You will get the effective capacitance as 3 by 4C. Do we understand this? Everyone understands this? Great. Now, what happens when you fill a capacitor with a dielectric? If you fill a capacitor with a dielectric, dielectric is nothing but an insulator. It changes the electric field inside the capacitor and the capacitance changes. If you fill it completely, with your dielectric, the capacitance will become K times. Do we understand this? Do we understand this? Who is this who is trying to gain control of my screen? Pawan, why are you trying to control my screen? I'm getting requests that you are trying to control my screen. What will you get by that? I hope you are not doing it knowingly. Don't know what you're doing. Anyways, so do we understand what do you mean by dielectric and what effect this dielectric has? When you fill, I don't think this is, this student is there, a part of us. So I'll just remove him. Okay. So I think it was some spam. Anyways, so this is what do you mean by dielectric. The dielectric is going to polarize your medium, and it changes the electric field inside the capacitance, and it changes the capacitance of the capacitor. I hope you have heard this term polarization vector, which is the dipole moment which gets induced per unit volume. Whenever you have a dielectric induced, what happens on one side, you will have induced negative charge, and one side you will have induced positive charge on the surface of the dielectric, and you have a net dipole moment induced inside this electric field, inside this capacitor. This induced dipole moment per unit volume is equal to sigma, and that is known as the polarization vector. I hope you have heard about this polarization vector. And then from here, you can find out that the value of electric field divided by the original field. We have an original field which is outside this conductor and you have a field which is inside this conductor, this inside field divided by outside field becomes your K. And hence you have this constant K coming into the picture. Do we understand this? Do we understand this? This constant K is known as the dielectric constant. When you have vacuum or air filled in up, what happens is whatever electric field is outside, the same, if you have a conductor, what happens is whatever electric field is outside, the same electric field is produced inside in the opposite direction, and hence the net electric field cancels out. But in case of an insulator, whatever electric field is produced outside, the same electric field is not inside, and hence there is some electric field which remains inside this dielectric, and the ratio is known as K. In effect, what it does is it changes the capacitance of the system, and the capacitance becomes K times. This K is known as the dielectric constant. Do we understand this? Can I have some raised hand that we understand this, sir? This gentleman has again appeared. I don't know what he means to do, why he wants to take control of my screen. Again, removing him. Is there anyone in this? Is there any office person? This some gentleman is coming and trying to take control of my screen. I don't know what he wants from that screen. The next time he comes, I'll report him. Okay. So now, once you have this dielectric filled up, you can find the effective capacitance of this system in different ways. You can call this capacitance as C1. You can call this capacitance as C2. C1 will become epsilon naught A by D1 into K1. C2 will become epsilon naught A by D2 into K2. Epsilon naught A by D2, and these two capacitors C1 and C2 will be in series. The effective capacitance will be 1 by C is equal to 1 by C1 plus 1 by C2. Do we understand this? How we can solve any questions on this type of dielectric field? We can convert them into a combination of series and parallel capacitors. Do we understand this? Can I have some raise hand that we understand this? Okay. Now there is another type of division which they sometimes call it as the area division. Here what we have done, we have divided the area. One capacitor, one dielectric is filled like this. You can call the capacitance as C1. You can call this capacitance as C2. Here area has been changed. Area becomes A by 2. So first capacitance becomes epsilon naught K1 A by 2D. Second capacitance becomes epsilon naught K2 A by 2D, and these capacitance are in series. If the areas are A1 and A2, you can put A1 and A2. If the areas are half, you can put half. Then you can solve it by the combination of series and parallel. In this case, they both are placed parallel to each other. Am I clear? Can I have some raised hand that we understand this, sir? Again, there is this spam. Why is troubling so much here? Why is troubling so much? I'll have to remove him. Why is troubling so much? Office people, I told you to activate the waiting room. Why don't you activate the waiting room here? All the students, they get into my class and the class gets disturbed. I don't like it at all. Okay, Now, in some cases, you will have, am I audible and visible to all of you? I have not muted myself. Okay. In some cases, you will have capacitors whose dielectric constant will not be a constant. So it is known as a dielectric constant, but it might be variable. Now, if it is variable, what you got to do is you got to break those capacitors into small capacitors. Sometimes they will be in parallel, one such strip, and the other strips are in parallel. You can find the effective capacitance by the integration of DC. If these elements are in series, you can find 1 by CS integral of 1 by C, 1 by DC. So this is how it is done. I hope you would be able to solve it. We'll solve some questions on this. Don't worry. But this is how it is done. Okay. Let me see if there is a question here on this. Not here. Let me see if it is here. Dielectric. Okay. Must be here. Okay. Now, you can solve this question just to find out if you understand the concept or not. Find out the capacitance between A and B if there are three dielectric slabs of constant K1 of area A1 and thickness D, K2 of area A2 and thickness D1, K3 of area, again distant. What is the problem with K2 of area A2 and distance D1, K3 of area A3 and distance D2. It is put in between the plates of a capacitor. What will be the effective capacitance of this system? Is there anyone in the office? Don't know how to get rid of this guy. Coming and disturbing the class more often or not. Okay, so how will you do this question? These two capacitors are in series. You find the effective capacitance of these two capacitors. Then this and this will be in parallel. You can find it out using the parallel combination and you will get the answer. Again, this gentleman has come. I'm losing it now. Okay. So how do you do this? This is how you do it. This is how you do it. You find the effective capacitance of C2 and C3. They are in parallel. It looks like this. Now, since the question is in A and K, that's why it looks very tough. If I would have given you the values of K, A, and D, that question would have become very simple. Then this C1 and this combination is in parallel. You just add them and you will get your final answer. Do we understand this? Can I have some reason that we understand this, how we have done this? Okay. Now, next is this one. This is again similar question. Here, the only thing is the area has been set. This area is half and this distance is half. So as you can see, as soon as you put this condition that area and distances are half, the question becomes very simple. Yes or no? Yes or no? The question becomes very simple. You can easily calculate it, finding the capacitance. Let me call this as C1. Let me call this as C2. Let me call this as C3. You can find the capacitance of C1. You can find the capacitance C2, you can find the capacitance C3, C2 and C3 will be in series and the combination will be in parallel with the capacitor C1. Do we understand this? Do we understand this? Okay. Now, many a times you will come across a question where you have such type of question, which is combination of parallel plates. Series and parallel combination, we'll do it in resistance. That time you will have more questions. So whatever we do in resistance, the same thing can be repeated for your parallel combination and capacitance. So we'll do it series parallel combination here. What one typical type of question that comes sometimes is combination of such parallel plates where you have, in this case, this is plate number 1, this is plate number 2, this is plate number 3, and this is plate number 4. Now these plates will be combined, will be joined in different fashions. How do you find the effective capacitance in this case, where you have different ways of combining these sheets? So what I'll do is, I'll do one for you. Here, plate number 1 and plate number 3 are joined to point A. Plate number 2 and plate number 4 are joined to point B. I will just tell you how to solve this question. I hope you can do the rest of the question on similar way. So the question was like this. I had 4 plates, 1, 2, 3, 4. I'll name them 1, 2, 3, 4. Plate number 1 and 3 were joined to point A. Plate number 2 and plate number 4 were joined not to point 4 but to point B. I have to find the effective capacitance between A and B. How do I go about it? I solve it in a very simple way. What is a simple way? First, I draw point A. This point A is connected to plate 1. I draw plate 1. Plate 1 and plate 2 make a capacitor. So plate 1 and plate 2 make a capacitor. So I make plate 2. So I made this capacitor. I cut this out. I made this capacitor. Now I look at plate 2. Plate 2 is connected to point B. So I connect the point B and plate 2. So 1 and 2 is done. Now I look at 2 and 3. 3 is connected to point 1. So I connect 3 to point 1. Then 3 and 2 make a capacitor, this capacitor. 3 and 2 make a capacitor, this capacitor. 2 is connected to point B. So I connect 2 to point B. So I made 2 capacitor. I made capacitor 1 and 2, which is this one. I made the capacitor 2 and 3, which is this one. The only thing that remains is the last capacitor. Plate 3 is connected to point A. So I connect plate 3 to point A. Plate 3 and plate 4 make a capacitor. Plate 4 is connected to plate 2 and both are connected to point 4. So I just connect plate 4 to point B. This is this capacitor. I made 3 capacitors. I've connected them accordingly. The capacitance of each capacitor is C. Now these 3 capacitors are connected in parallel. The net capacitance between A and B becomes C plus C plus C. The answer is 3C, 3 times A epsilon naught by D, where A is the area of these plates and D is the distance between the plates. Do we understand this? Can I have some reason that we understand this, sir? How we have done this? So I'll send you some sheets. You will have questions on this pattern as well. Solve those questions. And in the next class, we will be trying to deal with the circuits of capacitor. Circuit of capacitor. Someone is... Yes, beta, if you have a doubt, you can ask the doubt. You don't have to take control of my screen to ask the doubt. If you have a doubt, you can ask the doubt. If you try to take control of the screen, I can't allow it. So ask a doubt, just ask a doubt. I thought that you are a spam. That you are trying to control the screen and you will write something on my screen and hell will break loose. So I can't allow that. You can type your doubt as you are typing right now, beta. Type your doubt. I can't allow you the control of the screen. I'm sorry. Okay. So on that note, I will finish today's class. See you tomorrow in the next class. In the next class, we will be dealing with circuits and how to solve circuits and capacitance. On that note, I am end of today's class. Take care. Bye bye.